All right. So I'm going to talk about clean architecture tonight, and we'll also talk a little bit about how that might be implemented in .NET. Maybe take a quick break after that, and maybe I'll talk a little bit about Bright for anyone that's interested, which is an open source project I work on. I'll mention that again in a sec. Um, the headline, kind of, what is clean architecture? So clean architecture is the term Bob Martin used to say there are a number of architectural styles that he's seen people repeat effectively the same architecture. And his kind of assertion is we can kind of lump those learnings all together and create this synthesis of the whole idea. Okay. Most of this is kind of unimportant. The bit at the bottom I always kind of raise, which is I got started doing presentations back in about 2002. I was a C++ developer. .NET and Java were eating C++ developers' lunch. So I started to get into .NET. It's all very much in beta. And I started a user group in London because I could see people in America having fun at user groups. And someone said, I'll come to the first meeting if you start it. So I thought, well, at least there'll be two of us having a beer. And there were no experts, so we had to present ourselves. And that meant that I and some of the others who were there in the very beginning, we learned to stand up in front of the rest of the room and tell them about stuff that we discovered. And it's kind of friendly, right? It's a small user group. You know everybody. They're on your side. They want you to do well. And so that got me into it. And as a result, well, once upon a time, I used to kind of travel around these interesting places and do stuff. It also really helps in your career terms to be able to, that we have a sort of saying in English of see one, do one, teach one, right? Which kind of means you watch somebody else do it to learn something, you do it yourself, and then when you've kind of got a bit more mastery, you teach to somebody else in turn. And that model seems to work for me really well in terms of helping me organize my thoughts. Writer will mention actually tonight, so you'll see that. So I wrote the first version because I kept writing it in a load of shops that I went to, and it's been around for a while. And it solves both the same problem that Mediator does and the same problem that say Mass Transit does. All right, we're going to talk a little bit about what layers are about, layered architectures, because it becomes a bit key to understanding the clean architecture. We'll just talk a little bit about how we structure the main models in layering. Then we'll talk about the clean architecture itself, and then we'll go into a little bit of a loop talking about how different ways you might better implement that. So as I said, so Bob Martin wrote this book, Clean Architecture. To be honest with you, I wouldn't necessarily recommend you go out and read the book. There is if you don't mind reading his blog, there's a blog post on his blog, Eighth Light, which covers most of the detail that you need to understand about clean architecture. And probably you can get the rest of it out of this talk too. Bob's obviously a more controversial figure nowadays, so some people don't really want to engage with his output. It derives really from a lot of people who have co-invented the same idea, but the kind of standout ones that you probably may know of. Alistair Cockburn created an architecture called ports and adapters, sometimes called the hexagonal architecture because the way that diagram looks. Jeffrey Palermo in the .NET space created something called the onion architecture, again, very similar. And Ivor Jacobson, or even further back in time, created something called boundaries, controllers, and entities, which the diagram doesn't look that similar. We'll see quite why that is the same. And I'd also offer that even people who think when they talk about doing vertical slice architectures like Jimmy Bogart, when he talks about that, really they're not doing anything that different. And we can explain a bit how that works. Okay. We'll talk about layering. Layering comes with a little bit of a bad press occasionally. You know, you see the Twitterati saying, "Oh, you know, don't use layers, etc." We'll explain a bit why it gets bad press. A lot of it's about misunderstanding. So classically, when we think about layers, we might think about something that looks a bit like this, right? I've got a user interface which exposes my system. And by UI, actually nowadays, and we quite often say presentation, because it could really be that we've got an HTTP interface to a service and the user interface is, you know, all Jamstack or whatever, right? So it's somewhere presenting what something out of our application. And a domain layer, that's where we do the work. That's where we have essentially the business knowledge that we're implementing. Someone's paying us to write software. Generally, the reasons they're paying us to write software are what's in the domain. And then we also have some infrastructure. So databases, payment gateways, things we talk to. And the idea behind a layered architecture, it says, all right, we can divide up our architecture into layers. And each layer holds a responsibility within our architecture. And the layers at the top can depend on the layers below them. And the layers below them can't depend on the layers above. What we mean by that is, in the presentation layer, I can create an instance of a class in the domain foo, and I can do things with it. Right? And in my class foo, or from my presentation layer, I can get a hold of my repository over my database and create an instance of it and use it. But in my domain layer foo, I can't get a hold of instantiate some class like a web controller, etc. that I might want to use. I can't create one of those. I'm not allowed to basically go up. And quite often the metaphor that we use for this is a layer cake. So when you go to a wedding, in the UK certainly, maybe, I'm not sure if traditionally the same, you get these cakes of kind of 3 or 4 layers, each one slightly smaller than the other, and they kind of stand in a tall stack, right? Why might I want to do that? Generally, there are a couple of things going on. One's information hiding, just like an object orientation. So if I can expose a facade, like a thin layer over my domain with a fairly coarse-grained API, then what happens is the layer above, which calls me, doesn't have to know much about my implementation details on my layer. And that reduces the amount of coupling I have, because A, in order to talk to C, there's a reason why B's not here, by the way. A, then in order to talk to C, only has to depend on this coarse-grained API, if you like, to my layer, my facade. It doesn't need to know about the implementation details. It means I can change those details. If I want to change the way that let's say that in my domain layer, I have an algorithm that tells me when I'm going to ship my cargo from China to London, what is the best route to do that? Do I go via the Pacific and the Panama Canal? Do I go all the way around the bottom? How much is that going to cost? What stops should I make? I've got something that does that, right? So A may only really care about saying, I want to basically call something that says, given my origin port, my destination port, given I want the cheapest route, what is that, right? What are my options? The domain, in order to satisfy that, may have a whole host of entities that it deals with to calculate the routes, figure out the best path, etc. But I don't need to surface that. And if I then come up with a better way of implementing that shipping algorithm, then I can go and replace it. And my presentation layer doesn't need to understand my changes implementation details. And we understand this, right? If we do OO, we know that that's the theory of how our class works. We hide our state, provide methods. We could change the implementation because our collaborators only really depend upon our public interface. And the same down there with infrastructure, right? If I depend on a data access object or a repository, I don't have to know what SDK or ORM or whatever it is that you're using to actually reach out to the database are. I don't even need to know what database you're on, right? People push back against layers occasionally and they say, oh, I've never changed my database layer, but I've changed databases in a lot of places I work, but also more importantly, I've often changed the SDK, the framework I'm using to access data. I swapped out from Enhibernate to Dapper or whatever, right? And this enables you to do that. The other thing that tends to throw up a little bit is, by convention, we quite often talk about things like UI domain and infrastructure. That's just an example. And as I said, this could be presentation, that's called data, and it doesn't have to be 3. You could have 20 layers if it was meaningful to you. So domain-driven design often talks about having layers in the domain, right? Separating layers into sort of more top-level, coarse-grained things that call layers that are more fine-grained things below, etc. Right? And that may be important, but domain, it's for us to use however we feel it's appropriate. Okay. So we can reason about these layers as a whole without worrying about the implementation. I can just say, okay, I need to call my domain layer. I can have alternate implementations. Either I'm genuinely replacing it because I didn't work to have a better way of doing it, or sometimes actually for different markets, I have different implementations I want to swap in. I can defer decisions about their implementations. So one of the things that I can do here is I can say, well, this infrastructure thing that I need to talk to make the rest of my domain model work, that talks to this other SaaS-based service, I can move on and get everything working, but I can come back later and actually provide implementation. So I've done this before. I was working somewhere where we wanted to talk to a document repository, and there were various purchasing conversations going on between the company I worked for, various providers of document repositories, contract negotiations, and other departments like compliance becoming involved. But we were able to keep moving because we just built a simple in-database document repository that we could use as a kind of stub until the thing finally arrived, right? And we were okay because we knew that our interface to that layer was something we could swap out for a real thing later on, right? So this is where you get the ability to use things like, stubs and mocks. And we can minimize dependency between layers, right? If I have a course-correct interface between my layers, I reduce the number of points of contact. If I reduce the number of points of contact between my layers, then essentially that's going to make maintenance easier, because if I want to change something in that layer, the number of dependencies I may have could be quite small. One of the ideas we've been mentioning a few times is coupling, right? So coupling is our big enemy in software development, because coupling is the thing that ties two modules to each other. And that's what means that because I touched module A, I have to go and touch module B, I have to go and touch module C, and that's what makes maintenance difficult. And lots of architectural styles that you see are really around trying to reduce coupling. REST is right about trying to reduce coupling between the client and the server. It's trying to make sure that if the server wants to change the way things are done, the client can follow links, etc., and has lower coupling, right? Microservices are about reducing the coupling such that a team can work independently with another team. So coupling is a big force to try and improve our ability to change our software. The other thing is cohesion, right? So cohesion and coupling are usually talked about as a pair. If I was to take coupling to too much of an extreme and say, hey, I'm going to turn everything into a tiny thing, right? The problem with that is when I wanted to make change, I can end up having to make change in multiple places. I don't really want to do that. I want to make change in one place. So if I want to affect the shipping algorithm, I probably want there to be a module that does shipping. I don't want to have to go and touch 50 modules that all handle shipping, because that becomes a problem for maintenance for them, particularly if they're owned by different teams, right? And you see this problem emerging in microservices today, where you get Uber talking about their domain-oriented microservice architecture because they were too granular, and then you need to basically improve their cohesion by kind of wrapping a set of smaller services in a bigger microservice idea, right? And these forces, coupling and cohesion, are kind of imbalanced, and we need to figure out how to get that right. I often talk about the folktale of Goldilocks and the Three Bears. This bed is too big, this bed is too small, this bed is just right. And really, somewhere we need to get just right, where we're cohesive but not coupled. And layers just exist because they're a strategy to reduce coupling and increase cohesion. Right? People start saying, oh, layered architectures don't do that anymore, but they're pretty much a nice, easy solution to that problem. Okay. When I think about my domain layer, one of the things I think about is the fact that I can distinguish two types of business logic in my domain. Right? So one thing is the kind of domain logic that really relates to what the business does, quite often our special source. So how do I ship a package between two destinations, right? Given what your source port and your or the origin port and destination port is. How do I calculate an insurance premium for you, given your age and how many cigarettes you smoke a day and whether you ride a motorcycle, right? Those things are domain logic. They're where our business effectively is encoded into the software. And the other thing is application logic. So a little bit what we have to do is do some coordination, right, around that domain logic. So I may think to myself, well, the first thing I need to do in order to service this request you've given me to go and figure out the shortest path to ship my package is load up information on the port you're at, the destination port, load up information on possible routes on the ships that are available. So I'm going to go and load some state from a database. Right? Maybe as part of that, I need to talk to a couple of entities, 2 or 3, or maybe even some domain services. But I need to ask one thing a question, get a response, give it to another thing. Right, I want to do that calculation. So maybe I have to ask for, are you shipping a hazardous cargo? Is that going to reduce the number of ships that are available that could ship that? Are there some ports you couldn't go through as a result, etc.? Maybe I have to accumulate that data and finally give it to my route calculator. Right? So that's application logic. That's stuff we have to do on top of the actual domain logic of figuring out the shortest path. And so this is why B went missing in the early diagram. So we can often think about our domain layer as really having 2 separate layers. We can think about it having a service layer, which is our application logic, and an entity layer, which does our domain logic. And typically when we talk about an entity, what we mean is there is some state and there is some behavior that is coupled to that state, right? So I've got a class foo, and it has methods it has fields baz and boz, and any methods that basically use baz and boz are part of foo's interface as a class, and I hide, baz and boz fields from everybody else. They're my state, they're private to me. You just call the methods and I will exercise them on baz and boz's behalf. That's my entity. And then my service that lives above that says I can orchestrate those various entities, I can talk to the database for you, etc. Right? So you can see here, B could talk to D, could talk to the infrastructure layer for me. 2 ways of really looking at this kind of service layer that we've got here. One is that it's a very thin facade of the domain model. It really just is, hey, all I am going to do is coordinate all of the entities and domain services, and they're the things that know how to do everything. I'm pretty dumb, right? The other way of doing this is to say, what I really want to do is not put too much behavior actually in my entities. Most of my logic is going to live in this operation script at the service layer that does the work. We may say, oh, well, we build domain models, that's a bad way of doing things. But actually, there are reasonable trade-offs why I might want to do one or the other. In some cases, it is true that most of what your particular service layer needs to do for some particular part of your workflow is just save some stuff, right? And retrieve some stuff and display it onto glass. So it may not be worth building a complex domain model at that point. You may want to essentially say, you know what, I've got some classes that are pretty much as data structures, and most of my behavior is around the operation of them. And when that happens, it's okay to use that. And you can move between one and the other. You can say my service layer here is an operation script. My service layer here is dealing with entities. And maybe the operation script, I'll turn it into entities at some point, and I think I need to. Typically, we tend to have basically something at this layer where effectively we might have, whether it's traditionally implemented as I got a class, I called it something like, shipping service. I put some static methods on it, and effectively they would then call my entity layer or provide the operation scope, right? Very easy way to implement that. And they are really just a way of thinking of, they're the coarse-grained facade into my domain layer. Okay. There are better ways of doing it, but that's a perfectly adequate way of doing it to begin with. All right. So what's ports and adapters then? How does that relate to this discussion about layering? So ports and adapters, when people talk about it, or hexagonal architecture is kind of its other name. It is just a layered architecture. Okay. So people say, oh, we don't use layered architecture, we use ports and adapters. That's kind of a strange thing to say, because as soon as you use ports and adapters, you're using a layered architecture style. Right? And it has a few different rules, a few extra rules, but it is just a layered architecture. Now, a little bit confusingly, what ports and adapters says is right at the middle of our app is the application, right? Causes an immense amount of confusion, and what Alistair Cockburn means is the domain. Okay, so when if you look at Alistair Cockburn's notes about ports and adapters, he talks about ports around basically the application. The application, what he means is his domain model. He doesn't mean the whole app, right? Confusing. It's confused a lot of people as to how ports and adapters work. That's where the entities live. Around right at the outer edge, I have some adapters, right? And the adapters say I've got things that come in and things that go out of my app. So I may need to have, for example, receive an HTTP post and turn that into essentially an operation on my application. So the thing that receives my HTTP posts, the .NET Web API, for example, that's an adapter. It's allowing me to talk to things outside, or something that sits like a repository pattern over effectively my, something just like Entity Framework or Hibernate or Dapper over my database effectively has me access to it. That's an adapter, right? And in between, you have a port. The port is essentially how the application, or the adapter rather, talks to the application, right? It's a layer between the application. The adapter is not allowed to directly address the application. It has to do so via a port. Okay. And the idea behind the port is to say the port is this coarse-grained interface over the domain model, and different adapters can exercise that port. So this is kind of what it looks like. In the middle, in that hexagon right in the center, those little circles are supposed to imply to you, those are my entities, right? Those are my classes that possess state and behaviors over the state. In the kind of outer ring where it says things like user-side notifications, database and feed, those are my adapters, right? Some might have an HTTP adapter, so I can provide a sort of HTTP JSON API. I might have a GUI adapter so that I can provide razor pages, okay? We tend to think of these as primary. They're things that essentially tend to drive our application by providing the inputs, but we render output that way as well, right? We may also have other things like notifications. So when someone does some work, I may send a message out over AMQP, so RabbitMQ, right? Or any other transport of our choice. Maybe I talk to somebody else by WebSockets, right? Maybe I talk to them via webhooks or REST hooks, right? Even, or maybe I talk to them by SMS and an email adapter. And quite often that, instead of database, primarily what we're doing is kind of outgoing, and that's what we thought as secondary. Right? Okay. And all of these ways of adapting it, we can have multiple things that actually talk to the same ports that lie over the application, and essentially provide a slightly more coarse-grained interface over the application, like the domain at the heart of this, right? So we can obviously understand that my HTTP adapter and my GUI adapter might be different ways of me exercising the same functionality, right? So my GUI adapter, if it's a server-side rendered GUI, might directly call my port that expresses my shipping algorithm and say, hey, I can just type in origin port, destination port, type of cargo, and the port my GUI calls the port, and the port exercises the relevant entities, and those entities give me a response back. But at the same time, that port is something the HTTP adapter could also call in order to provide a RESTful interface to a phone client to do the same operation. Okay. So these ports are effectively acting very similarly to the service layer we were talking about in our domain beforehand. Okay, this feels very familiar. The adapter on the outside, application in the middle, and the port mediating between them. Okay. Now it's a layered architecture, but it has a slightly different set of rules. And the way to think about it is this. Whereas before, in the more classic layered architecture we saw, we had a model which said there's a presentation layer at the top, then I go down through the domain layer, and then I go down to essentially my infrastructure. Here, infrastructure, presentation, they're all the same on this outside layer right at the top. And they can talk down into my domain, which is divided into two layers, port in the app layer, basically, and the application layer, right? So the application layer is where our entities live. The port layer is effectively where our service layer lives. And the adapter layer is how we talk to our infrastructure and UI, okay? And that creates an interesting issue, of course. If our port layer doesn't live above our infrastructure, doesn't look down on it, how does it manage communication to databases or to messaging systems via AMQP, etc.? Because it can't create instances of things in the adapter layer that's above it, right? So the answer effectively is what we call dependency inversion. Okay. So if I need to talk from basically D some module in my port layer, a port. So this is my port that expresses effectively my calculate my shipping route. And I want to talk to the database to go and get information about ships that might be available in port. I can't talk to the database directly because that's an adapter layer. What I do is I define an interface. Say, for example, I call it, I don't know, a repository. And I say, okay, in that repository, what I can do is give it the contract that I need to talk to the database. Right? I'm defining a my layer, not the layer above. And it's essentially just an interface in C#, doesn't have an implementation. Then in the adapter layer, because it can look down to the port, it can say, hey, I can see that interface. I can generate a concrete implementation of that interface, right? So I can create an actual repository. And then at runtime, what happens is when something calls the port, so for example, A is an HTTP layer, effectively it's actually calling D here, the actual port, it can say, hey, you have a dependency on an interface, which is defined at my layer. I can new up an instance of that, provide you a real one in the place where you take that interface as a contract, right? Because it's in my layer, I can create one. And then when D calls a database, it's effectively calling out through the adapter defines E, but it doesn't know about that, just knows I've got an interface. And that is essentially where we get this idea of dependency inversion from, okay? And what IIC containers do for us. And really, when we think about the adapter layer, that's providing what we call the compositional route. The point where you kind of enter our application and you can new up pretty much anything, and then effectively the layer down below can new up things it needs, right? So you don't often always need to use an IOC container to do this. That depends on the complexity of your graph. But that's where we come from, this idea of dependency inversion, right? You can also use DI for things like open-close principle. I want to inject into a constant algorithm some variation in the form of a component that implements its interface. That's another reason to use it. But one of the main reasons to use it is layers, right? So let me keep my layer boundaries nice and clean. If you work with something that doesn't have this kind of layering and doesn't do this kind of model and saying, hey, I can't talk to one of these, then that's when tempting to get over coupled and into big ball of mud territory. Okay. So somebody else we need to care about now, apart from Alistair Coburn, who came up with hexagonal architecture, is Ivar Jakobsen. And Ivar Jakobsen is the person who wrote this book, Object-Oriented Software Engineering. You can probably find it at a second-hand bookshop nowadays. You can probably find a PDF somewhere online. I'm sure I was not losing any money by you getting a dodgy copy. And it's mostly famous really for talking about use cases. So use cases are this idea that we want to basically build against the requirements and acceptance criteria that our customers give us. How are we going to define those criteria? Maybe some kind of lightweight approach to doing that would be necessary, where we could define sort of some acceptance criteria, things that they wanted, not in technical terms, and implement it. Use cases in user storage are very similar. Use cases went a bit after Ivar created them a bit awry and became quite a complex technique. And they weren't really originally. They're very much more similar to user stories. And indeed, Alistair Coburn has a thing where he talks about, agile use cases, which are very close to user storage, a bit more formal. So here's something to a use case diagram, right? And this use case diagram is about ordering food in a restaurant. So imagine maybe we're defining a software that runs some kind of PDA that the waiter has, that talks to the EPOS system that we use for actually paying the customer's bill, etc. That talks to some ticket management system that lives in the kitchen so the chef can cook stuff, right? So I, as the client, effectively in the middle, come in, and one of the first things that I want to do is I want to order food, and maybe I want to order some wine, right? And the waiter with his PDA, they can receive their order. And those little circles, they're use cases. Order food is a use case. Order wine is a use case. Okay. And then that gets sent to the kitchen where the chef can pick it up and he can cook the food. When it's ready, the waiter can come over and serve the food. So cook food and serve food are use cases, right? And you can just extend things so you can extend a use case. Serve wine if I've ordered it, right? Some of you are probably Catalans, so I'm sure you drink wine with your food all the time, right? Then we can basically eat food, right? It's a weird use case. I'm not quite sure how we'd automate that, but we could eat food. I like to do that myself rather than getting a machine to do it for me and drink my wine that I ordered. And at the end of my meal, I may want to go to the waiter and say, give me my bill, and he can bring over something that says you can pay for the food and use a credit card. Whatever. That's what use cases are. And you can see that's very similar to probably user stories that you're very familiar with. Right? So Ivy Jacobson said, you know what? I think it would be really useful if we could express the idea that I'm building an architecture around using use cases in my architecture. I want my architecture to express the idea with these use cases. They shouldn't be hidden. The use cases should be surfaced. Nowadays, we talk about ideas like evident architecture or streaming architecture. That's kind of the same idea. This idea effectively that when I look at my architecture, I should be able to say, hey, that use case that I've defined in the requirements, there's something that represents that in my architecture. So Jacobson's answer was something called boundaries, controllers, and entities, right? Now, hexagonal architecture is the first of the ideas that become synthesized into clean architectures. This is the second one we're going to talk about. So, like I said, there's a thing called a boundary, okay? This is a UML diagram symbol, by the way. If you go and get some tool or like Draw.io or Visio and get your UML template, you're probably still there. And a boundary object says, okay, this is something that interfaces with system actors. So users outside the system, gateways to databases or payment providers, proxies, that kind of, etc. Right? Sound a bit familiar? The other thing Ivy Jacobson said, I get my system at entities, right? Things that basically have state and the things that operate on that state. All right, again, sound familiar? And he said boundaries shouldn't be able to talk to entities directly. That needs to be mediated by a controller, right? And the controller effectively says, hey, outside world, you want to do something. I will run the application workflow over the entities to make them respond and do that work for you, okay? And what we end up with is something that looks a bit like this, okay? I've got a user, they talk to some boundary objects. They in turn invoke control objects, which in turn invoke the entity objects. So funnily enough, that looks very similar, right? My boundary object is just my adapter, which is effectively my infrastructure and UI layers, right? My way of my application talking to everything outside it, right? If it's a Docker container, I would need to expose ports here. My controller object is just like my port, that coarse-grained wrapper over my domain layer, right? And my entities are obviously part of my application, part of my domain layer. And the thing that Ivor was saying is, hey, the controllers, that's where I find the use cases, okay? The use case, that's where it should be. So if I have an order food use case in my diagram, there probably is an order food controller, okay? So later we renamed them as interactors. The reason for that is people got confused between this and model view controller. So we started to call them interactors in this model, right? So my interactor as well is my use case. So if there's an order food use case, there's probably an order food interactor that handles the process of me ordering my food. Okay, and that talks to the relevant entities underneath. And interestingly, what Alistair Coburn, I remember Coburn writes a book on agile use cases, says is a port is the use case boundary. Okay. Use cases become problem when it focus on technology concern. A use case written report aligns those concerns, focus on application rules. In other words, because it's beneath that adapter layer, my use case doesn't care about the technology used to deliver it. It just cares about the rules effectively that the use case expresses. So we can see that this is essentially the same, right? I've got this layer, I've got this entity layer right in the middle, state and the methods that operate on it. I've got this boundary layer on the outside. Things that my application is doing to do I/O to the outside world. And I've got this control object that's mediating the conversation between the two. And it's coarse-grained and it effectively maps the use cases. There's also, and many of you know, I talk a lot about test-driven development as well, a reasonable correlation between the use case boundary and the test boundary. When our tests we think about and tend to focus upon the requirements of our system, one of the things that we could think about is that our tests actually are focused really on use cases. Right? Our tests want to exercise use cases more than they really want to exercise entities because they want to exercise the behavior of our system. And tests at this level are nice because they avoid having to basically couple themselves to the adapters, which do change over time. I might change how I basically access the database. And then I said they focus on essentially our application logic, which is the kind of best use of TDD. So here we can see effectively that we can imagine driving our unit tests against the port, and effectively our unit tests become another adapter for our code. I could drive it through the HTTP, through the REST interface. I could drive it through the GUI, and I could drive it through my tests. And my tests are exercising exactly the same coarse grained interface that those things are, right? And that lets me have those entities as kind of an implementation detail I can change if I need to. Okay, and generally we don't want to basically test our adapters too much, technology concerns, or really our database adapters via TDD. We might want to automate those, or protect them against regression, but generally they're not great TDD candidates because they involve us in lots of things that basically are hard to get under test because they're slow, they have shared state, etc. Okay, and they're unreliable and fragile. So quite often we want to automate them and not be compiled by TDD suite. I mean, maybe some system tests at the boundary to help us finish that. All right. Okay, so that's only two examples of showing you hex and boundaries, controllers, and interactors of this kind of approach. Onion would be much the same thing, so not much point in laboring the point, but I'm sure you get this idea. The heart of what we've got is some kind of set of entities that form out to be our application, our domain model. On the outside boundaries, the stuff that does the I/O, in between it, this kind of coarse interface over our entity layer, which basically is our ports layer, our use case layer, actually our interactor. So this diagram is essentially just the simplest of that. This is a diagram basically of the clean architecture. Okay. Right at the heart of it is my entity model, right? Surrounding that are my application business rules, my use cases in that layer. Okay. Around that, what we would think of as interface adapters. So they're the bits we write in order to basically work with frameworks quite often that we have. So my web API controller lives here, and this interface adapter layer. My concrete implementation of the repository pattern wrapping my entity framework lives here. Okay. And right on the outside lives these kind of either the libraries or frameworks I use to do I/O, or even the I/O devices themselves, right? Okay. And remember, we're depending inwards. That's what that arrow on the left-hand side is trying to make us remember. Everything on the outer layer can essentially instantiate things in the inner layer and not vice versa. So we've probably got some dependency injection between at the use case layer. Right? Okay. We wouldn't tend to, by the way, have much dependency injection at the entity layer because it's unusual for us to really want to use a use case from an entity. It's in theory possible, but we don't tend to do it. So this is another way of seeing that diagram that can be quite helpful. I have a delivery mechanism, something that's doing I/O for me, a razor page, a web API, basically route or something. I don't know quite how to describe that. An HTTP endpoint, right? And I've got a boundary layer. That's what I'm writing that fits in with that. So my controller, typically in say ASP.NET, right? In Brighter, if I'm bringing messages from outside of the MQP, that's my kind of handler layer, right? And then essentially what gets passed to me is a request model. So usually something at doing the I/O will take something like the query string parameters for HTTP plus the body, parcel it up into basically something that I understand as basically some kind of type, and pass it in a parameter as a parameter when it calls my boundary. Okay. And generally they're data structures. Generally they tend to have state but no behavior. Okay, that's where they're that gray color. And then what I want to do at my boundary layer is not essentially deal directly with my entities, but I want to talk to my interactor, okay, my use case. So I call this coarse grained interface. It then goes away and exercises the entities. Okay. What I may also need to do from that coarse grained interface interactor is do things like call secondary adapters like an entity gateway to say, go and get my state, or go and talk to a payment gateway, etc. The result of that will be some work being done and a response. And my interactor returns a response model which goes out by the boundary. It may be the same boundary that came in. So I may be returning, for example, a response to an HTTP request. There could be something else, right? I could be publishing a message over RabbitMQ, right? And that's equally a response model that my interactor has to essentially push out for me, right? So that would go to a different boundary on the way out. So here you can see us showing exactly what we think that is, basically for an API framework, web controller. And we can, if we do have any kind of MVC approach where we're saying, actually, I've got some kind of model in here, which effectively I want to use my kind of model view controller over, where I'm taking that presenter interface and I want to essentially see that as being something where I could write tests of some sort. Then really that lives here. The response model is the model we talk about in model view controller, right? And the presenter effectively is how we might render that onto the surface. We wanted to test how we're rendering effectively, say, our DTO response into JSON. That lives here. That's nothing to do with our interactor, right? Just so people understand that in the clear. That MVC and this are separate kind of concerns. And yeah, this is how we talk to this, so it gets up in and out of the database. Okay, so it turns out that one of the ways we might want to think about implementing the interactor that's very useful to us. We talked earlier on about this very simple idea that we could just say take a class, give it a whole lot of static methods, name those after use cases, right? That's okay, but that breaks down pretty fast because essentially we end up doing a lot of work in that. One of the other models that's very useful is a command. When people talk about the command design pattern, actually one of the things that's mentioned about it is it's very good for implementing a use case, right? And so this would be a specific use case, like order food would be a command, right? I'd have parameters to it. What is the order consist of? The way the command pattern works is this. I have a generic kind of interface called command, and it has one method on it called execute, right? And I create a concrete command that essentially has an execute method which exercises my entities in my domain model. And then effectively my client essentially, although it thinks it's dealing potentially with an interface, actually exercises my concrete command, which executes some code in my entity and gives me a response back, right? And the receiver is one or more entities, right? Very simple to implement, right? This is what it kind of looks like. It looks like the idea of saying I've got basically a interface called execute, and I've got some implementation of command. The parameters to my command go into the constructor, and then I just execute and I do stuff in my domain model. Commands are nice because they form an inherently easy to understand transactional boundary. Okay? I could think of this as basically starting and beginning a transaction in my database, for example. Well, I can think of it really also, in other words, of preserving invariants, right? I can say, hey, you know what? There's some things that should be true at the beginning of my command or before I execute it. I execute my command, and during its execution, things may be in an indeterminate state. And when it's finished executing, things should be again in a determinate state. So commands can be very useful for dealing with that notion of basically preserving invariants. And you can see that here in this model. What we're saying is that the boundary might interact as really a command. And I've got some concrete command that actually exercises my entities. And the fact there's an interface means I could swap it out for different commands and essentially be able to do different behaviors for things like feature switching or whatever. Okay. That kind of ability to swap commands can be made a little bit easier if we use what's called the command dispatcher. So the command dispatcher essentially says I can parcel that command object pattern that I had earlier into two things. The command, which is essentially the parameters, my food order, the origin and destination port for my shipping, and the handler, the thing that essentially calls the entities. Okay? And what that means, which is quite interesting, is that my client can essentially say, what I'm going to do is create an instance of that command, and I'm going to send it to a dispatcher. And the dispatcher essentially will route it to a handler. and the handler will then execute the actual action. That means the client doesn't need to know about anything about who handles this command, which makes it much easier to swap one for another. Effectively, I'll do some complex routing based upon variable factors inside the actual command itself. And that really separates cleanly my adapter layer, essentially from my boundary layer, from my application layer, because I don't even really have to know quite how the port decides to call with various given entities. I just now need to call a port, and it effectively handles all that routing for me. Okay. All right. So let's have a kind of look at how we might do that. And I will just switch between this and showing you some code. Let me see if I can get this right. Okay, I am going to share this with you guys. When you have multiple screens, you can sometimes find yourself trying to figure out where Zoom has put things. Right, okay, that's where Zoom put that. Okay. All right, Zoom, thank you for moving all my windows around. That really helped me. Okay. So hopefully you can see Ryder. Great. Awesome. So this application is the world's most over-engineered Hello World application. The problem a little bit for anyone doing talks at user groups or conferences is I need to give you an example that clarifies something for you, which in this case is how I might structure my application to support this model without drowning you in complexity. So just be aware that probably using this kind of clean architecture approach in the context of what this application actually does is enormous overkill because there's no real domain logic, right? Let's imagine between us all that there was incredibly complex application logic here that I was actually seeking to move out, and just focus really on the structure. That's what you care about understanding. So I have here essentially this is the API that effectively I'm going to implement here. And it's basically something that gives me a really simple model. In the background, I'm just going to go somewhere you can't see. And I'm just going to start up Docker so that effectively I can demonstrate how this ought to work. I won't necessarily keep running. So what I've got is a series of branches. I can share links at the end to where this is. And the branches represent transformations but of different approaches to implementing this. In the background, I'm running Docker so I can actually run this, but I won't keep running it all the time because it just looks the same. Okay. And what I want to do effectively is do something that says, hey, I can go away and run an HTTP request, and I can go and say, go and get me all the greetings you currently hold, right? It's currently holding none. Those of you who don't know, Ryder much like the REST client in Visual Code, Ryder supports basically things with a .http extension. It will effectively treat them as API calls. And nowadays, to me, it's a much nicer alternative to things like Postman. Right? So I can go away and get that. You can see it popping out in my app window at the bottom of Ryder. I can add a greeting, right? So I'm going to post my greeting hello world to my backend. And you can see in the app window at the bottom that's saying, yes, response code 200, 410 milliseconds, which constraints on my machine is appalling, isn't it? And effectively, I've stored hello world. Now I should be able to do a get. Contents from the database should have changed. Hey, I've got hello world, right, it's back. And I could add a few more greetings, right? I could go add a greeting from Mary to Mary wants a greeting, and when I do get, yep, I can see now I've got hello world and Mary, okay? And generally, there's something I can see all the greetings here. Yeah. Okay, right. Yeah. And I can actually effectively, I think I can see a specific greeting. What I have to do is cut and paste in the relevant GUID. which is never as easy in tooling as it seems. Let's try that. Okay, I should be able to see that specific greeting as well. Oops, illegal character index 36. I don't know what I did there. Oh, yeah, that's nothing to do with my, that's a marker for Ian to remember he wants to replace that. Okay. Great, I got specific greeting back. Okay. Awesome, that looks really cool. Okay, let's go and have a quick look at how this is implemented. And at this point, we've not done anything particularly interesting, right, in the implementation. So we've basically got a greetings app kind of thing everyone might write. It's basically web API, and I've effectively written my controller, right? And what I've done is I've essentially put everything into my controller, okay? So I've got an HTTP GET operation, that's why I get that greeting, right? And I'm going to go away and grab a greeting context, it's just entity framework, grab my context, and I'm going to say, hey, give me my greeting by the ID. And then I'm going to transform the result of that into something that I can then represent out in the wire, right? So effectively that seems pretty straightforward. I just go away and this unit of work, which wraps my greeting context, by the way, is it's providing me with some little functions. But great, I've got all my greetings. Excellent. I can do something down here. I can get all of them. Post, which is, ignore the console write line statements for a minute. Post is essentially going to go and effectively write my greeting away effectively to my data store, right? And then I can go and grab it back out again so I can return the response to the thing I just added. All right. We won't dwell on that. There's nothing there that I think you all haven't written 100 times. What's more interesting is that what we've been saying earlier is we shouldn't be slapping all this stuff into our controller. We want to have a few layers here to help us basically move forward. Okay. So the first thing I might choose to do is say, hey, I could replace that thing, those calls in line in my controller with a layer that essentially lets me deal with that instead, right? This notion of a service layer, right? And it's putatively, effectively my use case layer, right? And so you can see what I've done here is I've created this thing called greeting facade. Look at greeting facade briefly. And greeting facade essentially says, all right, all those methods that you were calling, I'm going to essentially deal with that. I'm going to have this thing that adds a new greeting, right? And I have this thing that gets you all the greetings, deletes the greetings, etc. It's very CRUD based, right? It's an example. You want real genuine things like ship port to port. I've got this horrible thing about re-greeting. At least I kind of know what it is now. Sure, write in the console statement, but whatever. Okay. But my controller looks a lot cleaner, right? Because what I'm doing now is just calling those operations down below. Now, I'm not going to write any tests in this particular demo because it's not going to really help us. But hopefully it's clear that writing my tests against something like, oh, you know, my facade, etc., might be really useful. And possibly, effectively, you know, where I'm doing all that option stuff, I could begin to think about dealing with in-memory database or whatever instead. Right? So I can inject in something that would effectively mean that at that port layer, I could do some replacement for the purpose of testing. Right. That looks quite nice. I've got this facade. Well, the facade itself, when I looked at it, that's a bit ugly, right? A lot of stuff in there. And there are interesting things, right? You know, if any one of these needs to change, in theory, effectively, I've changed this particular whole class, and maybe that's not the best thing to have done because they're now, you know, I've coupled these each to each other. More than that, though, it's not really a very good class because there's no real state that these things are dependent upon, etc. So it's got multiple responsibilities. It controls multiple use cases. Maybe I could fix that, right? So maybe the simplest thing I could do to fix that would be to slice it up. All right. So in my greetings controller, rather than dealing with this big facade, why don't I slice up my facade to have one for each of those use cases that I'm dealing with, right? So I can have my essentially service that basically says, Greetings greetings by ID service. All right, again, look at that. It says, oh, I'm going to do the thing that basically does the query for you, right? So you can essentially pass me the parameters in the constructor and I can do the query. Oh, I kind of like that. I like that for the reason that I'm now dealing with state and behavior on that state. By the way, a little tip I give people occasionally. So sometimes a lot of us are using tools that when we write a class, it'll say this method could be made static. And the reason it's telling you that this method could be made static is because that method doesn't use any of the state in the class. Okay. I would suggest to you that your response to that is not to make that method static. Okay. Your response to that is to recognize that you probably have a collaborating class that you want to deal with. And you should take the parameters to that method and make them parameters to a constructor of a new class that has a method that doesn't take any parameters that essentially exercises the behavior that's currently in that method. Because now you have state associated with behavior. Essentially what we've done here, we took that big facade, right? And we said, well, let's just basically turn something smaller with state and associated behavior in the state, right? And I've got my greetings ID by result is tagged in here in the same file because I can tag more than one class in a file. That's the return value from that. That's quite good. It's clean. I quite like the way it's working. I've got something that adds a greeting. Okay, we can look at that. That's pretty cool. It's basically, getting in my repository, the message, awesome. And then effectively I go away and I save that message into my database. Awesome. That's pretty good. And you can imagine if there's a complex business logic, I've got some stuff coming in basically in the constructor, which represents the destination port, origin port, and I'm doing whatever work I need to do, right? Go and get basically information about what kind of cargoes ships can ship out in my database. Awesome. All right. Well, that was nicer, right? And certainly my controller is nice and clean. And I can certainly imagine I could write tests against one of these things. So if it had a lot of domain logic inside it, right? Add greeting service, I could target it on my tests. And that's my kind of like my boundary, my use case line. Awesome. What else could I do? Well, all of these look a bit similar, all right? So if I look at add greeting service, I pass in some parameters and I call method to do the thing. Greeting by ID service, I pass in some parameters, I call method to do the thing. Isn't that just the command pattern, right? The command pattern effectively, I give it some parameters and I call execute on it to do a thing. Okay, why don't we actually do that? We're going to turn this now into basically commands. Okay. It doesn't really look that different. Greetings by ID query, right? When I look at that, basically it's an I am a query, which returns a result. I look at that interface, right? Okay, I've got some generics. I'm saying when you basically call my execute method, I'll give you a result back. And obviously what you receive is as part of your concrete type, right? Interesting. Okay, and that's basically doing something, taking that facade I had before, making it to that. And similarly, if I go and look at my add greeting command, right? So command is do stuff, query is ask questions, right? And my command is going to basically go away and add that, right? And that's quite nice. And it's basically based on I am a command. It doesn't need this generic interface because its return type's not generic, it's just returning void. But I could choose to return from a command. I mean, normally commands don't return anything. That would be the original idea, but I might choose to just for simplicity. But here I'm able to do quite easily is issue my command and then query for the results. That works me fine. Okay, well, that's quite interesting. It certainly looks pretty clean, right? I can say, hey, post goes to where effectively creates an add greeting command, greets that, executes that. It looks at a regreet event listing that basically says to the console window, hey, I received a greeting. I can do that. Awesome. Yeah. Although the only thing is I've coupled my controller to these concrete implementations, right? And what happens if really, though the parameters are nice in the package here, I wanted to dispatch it to somewhere else. So what I could do is basically use a command dispatcher. All right. Overwhelmed my ID with the changes. And so what we're going to do this time is actually bring in, let's turn to solution file system. No, packages. Packages. I'm going to bring in brighter and darker, right? So this is the open source library I mentioned that I work on. Okay. Brighter and darker are going to do query and command side. So brighter is command side, darker is a query side. What they're going to give us is essentially definitions for things like command, etc. So when I'm going to create an add greeting command, it's a type command, right? And that's going to come from brighter. Decompiling an external source, come along. It's just basically got an ID, it's derived from something called a request, etc. Right? And darker will do the same. We'll have basically a query that derives from something. Okay, query processor. And you can see this is the idea of it returns some type of result, right? Excellent. Okay, and very similar to us. And what we'll notice what we're doing is we're passing them to an executor, right? And when I look at the concrete implementation of, say, my add command, it's just basically got state, right? It's the state, it's the parameters to my command. It's not doing any actual work, okay? So what I'm passing it to figures out where to route that, and it routes it to something essentially that can handle it, right? And though what it routes it to is effectively my port, my use case controller, okay? Now, I may find that it knows it's got 2 ports. I have to switch to the file system again. I've overwhelmed its capacity to adjust as I switch branches. My port, essentially, right, where these commands live, also has handlers. Right? So my add greeting command handler, don't worry about this stuff in a minute. It's just doing the same thing that execute body of that command used to do. It's essentially saying, go and basically save this value into the greeting repository. And it takes its parameters from the command that's been passed. Okay. And a query is kind of very similar, right? So receiving a query and going and doing the work. What about all these things a little bit? Okay. To get that working, what I essentially need to do is hook stuff up. And this will be older code, which I demo a lot. So nowadays, we've basically got support for host builder. And so as a result, we don't have to worry about doing half the stuff by hand, but I'll show you when this pops out. Where am I doing my, oh, the app at the top, right, so, okay. Configuration and startup. Okay. So as I say, host builder does all this for us now, but a lot of this is DB stuff. But what you want to understand a little bit when you get down here is register command processor. Okay. So the idea is what we need to do is just register some handlers for given messages. When we look at these lines here, what we're saying is the add greeting command gets served by the add greeting command handler. Regreet event gets served by the regreet event handler, right? Okay. And then effectively we take this table and we create a command processor with it. Don't worry about the other stuff in a minute, we'll come back to that. And it's the command processor call in the controller that essentially is routing the command to its destination for us, right? Where there's send async method, and then it's basically enacting what it does. Okay, all right. What are some of those other things that we looked at? So it's got some attributes, and they say request logging, use policy async, right? What's actually going on there? Well, we can go and probably use a decompiler to go and have a quick look. So request logging async is using this request logging async handler, which is basically provided to us. Well, we can see that's actually also a handler, and it's got a handle async method, just like we have. And what it's saying here is basically, it's going to effectively call our some kind of inner handler, but it's going to log the command, right? And we've got some stuff here that appears to be doing some kind of logging for us, right? Okay. What about the other one? What is that? That decompiled code is a bit confusing. What's this use policy one doing? Okay. That's saying exception policy handler async. Okay, what's that doing? Well, okay, it's actually a bit more confusing as async code, but it's saying call this basically policy execute async. What's policy coming from, right? From poly, okay, right. And so what we're actually doing here is we are building a chain of request handlers. So this request handler, we can think of as the data sync in a pipeline. The data source in the pipeline is essentially the command processor, right? And it's saying, I want to pass the command down a sequence of steps. And you can see that effectively we've got this step indicator indicating what the sequence is. What this is saying is the first thing I want you to do is log that you can send a request and show what parameters are. The next thing I want you to do is to set up basically a poly policy around a circuit breaker. Circuit breakers are things that essentially say, in the event I get enough errors, stop sending me messages. So this would effectively just say, hey, I'm not passing that request on, the circuit is broken. Right? And inside that, a retry loop, right? So we're using a poly policy to say, hey, if this fails, retry it. And this kind of effectively is what we call a Russian doll model. Each one is calling the one inside. So in this particular model, we're going to log the request. We're going to ask the circuit breaker whether we need to break. And we're going to basically call the retry handler and say, oh, we need to retry. If I get an exception, what will happen is the retry handler will catch it. If it's one that we've set up to be retried, it will retry it. If it fails to basically on the retries, it will fail. If the circuit breaker counts enough failures, it will suspend basically effectively us using this until a certain amount of time has passed, whatever our criteria is, essentially, right? And probably will log on the way out. Okay. So we've lifted some orthogonal behaviors that we don't want actually polluting our application workflow out, and we've turned them into basically part of our pipeline. And that's one of the big reasons to use a command dispatcher, is to establish a pipeline between the caller and receiver in which you can do orthogonal work. And actually, really, that pattern is more probably called the command processor, which is why we call it command processor and inviter, effectively, or query processor. And similarly, the query processor effectively has, where's my query processor effectively? Gone. See this one. Okay, query processor. What my query processor? Greetings by greetings by D handler. Right. We've got slightly different teams work to actually got some different naming conventions, but we're saying, yeah, log the query and make it retriable, right? The querying is a slightly different model for how it assigns policies. And if we go back to this adapter, we can see, hey, one of the things I'm doing here is I'm creating a set of poly policies, right? I'm putting them in a policy registry, and I'm giving the policy registry to my command processor so that it can find those policies which I mentioned by name in the actual handler, right? Not there. Close some of these windows. If I close them all down, I better find stuff again. Right, let's just assume we do that. Okay, so mention the policy is that name, and it references the two, the name of the policy. I go and put the policy in the registry, I'll apply that policy at this point. Okay. The query processor is doing a very similar thing, right? And although I accept this setup code looks a little bit kind of long-winded, nowadays actually you just tend to do in host builder add brighter, right? We do most of this for you. You still have to define the policies that you want to use, but we'll go and look up commands and map them to handlers and that kind of stuff. All right. So the only other thing to show you at this point is not quite related to being architecture. Is just to show you, but I can also use this in the context of messaging, right? This is a greetings worker. And my greetings worker effectively needs to build a dispatcher. And again, this is really simplified nowadays by host builder and us being able to essentially use brighter effectively here. But essentially in the host builder, what we're saying is, hey, you know what? What I would like to do is connect this up to RabbitMQ. I would like to listen to messages from RabbitMQ. When you get those messages from RabbitMQ, what I'd like you to do is translate the body of that message into something I understand, like a reroute command. And then I would like you to basically make sure that when you dispatch reroute commands, they go to this handler. Oh, and I've got some poly policies I'd like you to use around that. And in return for you doing a little bit of setup, what I can then do is essentially listen for incoming messages on RabbitMQ and get them to call this method. All right. So regreet is essentially allowing me to send a message while publishing, basically when I'm done. I think if I look in the add greeting command handler here, you'll see basically I do command processor post that's saying send this not internally on my, I feel like in my internal message bus, but send this externally over a message bus like RabbitMQ. And a worker process can then listen for those messages. And this worker process will then call regreet command handler. So we're simplifying now that model where effectively you're saying, hey, here is a port that you can effectively have subscribe to the framework, but in order to get dispatched messages automatically. And I don't even need to write an adapter layer here. Essentially, the adapter layer doesn't exist as far as you're concerned. It's kind of basically you just write the port and we'll dispatch straight to it. All the adapter will be forward it. Okay. And I'll talk a little bit in a tiny bit. Maybe we'll have a 5-minute break. Those that want to listen to it in a second about pricing. Okay. All right. That's probably a really good point to just check if there are any questions. So I'm going to stop sharing before I've got a few summary slides at the end. Let's have a quick look in the chat. Okay. In the VT's demo project, is there any repository like GitHub or something like to download? I'm glad you answered that question. Yes. It is. It's in my repository on GitHub. Let me find you a link and post that into the chat. Anything I talk about, any of my presentations effectively lives in this file, like all the PowerPoints and stuff. I'll post in just a second a different link, which will go to the Slack window. Where did you decide to hide my Slack window? Right. So slide decks and everything else get for everything I do goes in there, right? Okay, now this the code is also tends to live in this repository, and the code for that particular tutorial. Remember, you have to kind of switch branches to see the evolution. Lives in here. Okay. All right. Question about Mediator. Mediator does do the in-process stuff, but doesn't do the out-of-process stuff. So Mediator will effectively take a command and dispatch it to a handler and do it in process. It doesn't support out of process. Okay. Let me just say that we came first, right? We existed quite a long time before Mediator did. And Jimmy kind of fully admits he basically went out and just stole from other people and built Mediator to be a simple version of just the functionality he needed, not the other things, right? So it's not that we went and re-implemented Mediator. Let's put it that way. All right. Okay. All right. Some more chats. I don't know whether those links will show up for folks in YouTube on the chat, but we can always share those at the end via the user group, so you can all get access to those.
Yeah, I'm sharing them in the meetup.
Oh, awesome.
So yeah, I'm copying, pasting there.
All right. Let me go back to share a bit and get through the slide deck that's left on here. All right. Oops. Oh, actually, that is that slide deck. I didn't have anything else. So what I was going to offer to do was I can talk a little bit more, if you like, about writing. Those that are interested in having a little bit more of an overview of how it works. I thought if anyone has any more questions, we can do that first. If anyone wants a 5-minute break, quick comfort break, before we actually get into Brighter, that'd be okay. How do we feel organizing?
Yeah, I can. Yeah, I have a couple of questions that I think they could be interesting.
Yeah,
that probably people. Yeah, first. It's about testing. That's very interesting thing about, because people are trying to do TDD from inside out, right? The outside in, you know, this. So what's your point about that? I mean, we have limited time to do testing in the projects. We would like to test everything, right? but
Yeah.
people start to say, okay, better to do a lot of unit testing and the other stuff, maybe manual testing, or other people say, okay, let's automate from outside better. So what would you do, your approach? What?
Right. So I did a couple of talks on TDD, right? I did one you can see at NDC very easily called TDD, Where Did It All Go Wrong? Which talks a lot about this in more detail.
Exactly.
I also I have a newer talk, which is probably hard to get a hold of. I haven't got it many places. Talk to your lovely user group organizers. I can come back and do that another time, which is kind of a slightly, it's a 7 years later, slightly more organized take on that. So here's my thing. We lost our way in test-driven development because we began to deal with this idea of unit testing, integration tests, and system tests, and they come from classical testing. And what test-driven development, as originally meant, was actually what we call developer or programmer tests. And you can go and have a look on something called the C2 Wiki if you like, which it's kind of a repository of knowledge for a lot of the discussions that happened in, say, extreme programming and early agile communities. That thing is that a test is not, what unit testing says, I need to isolate the unit I test so that I can tell that failure belongs to that unit and nothing else. TDD says when I add code as a result of writing and implementing a new requirement, then if there's a failure, it's in that 10, 20 lines of code that I added. I work in small steps, I add 10, 20 lines at a time. If that 10, 20 lines that I added doesn't work, I can revert it or I can debug it, right? Default localization is based on the lines of code I just added, right? That's what breaks things. TDD doesn't basically have a whole model of using mocks very much. It only really uses mocks to replace IO. Unit testing has, I mock out all my collaborators. TDD doesn't care. TDD is focused much more on the coarse-grained API. It's a design by contract methodology. It's saying, hey, what is the contract of my API to my layer, for example? I'm going to explore that for the process of test-driven development. And I'm going to implement enough inside that module or that layer to satisfy that requirement, nothing else. There's nothing mechanism for scope control. So TDD does design and scope control. That's why you do it first, right? It's not really about providing test coverage. It's just a nice side effect of the whole thing that I can continue to prove that my design works. It's like a provable design, and it should give you examples. If you throw mocks at everything, you'll lose the ability to see your examples, and you'll couple your tests to your implementation if you don't want. So this model says, well, what's the thing that I want to really test? It's probably my entity model where effectively I've got plain old C# objects, right? That's what I want to test. Maybe it's the domain service in there, which wraps a few of those. That's quite a nice thing to test. Maybe it's the use case itself at the port. So those tests in that handler, I can call that handler. I can provide mocks for the things that essentially that handler has interfaces for, because they're things in the layer above, right? The same layer of my tester. I can mock those. They are suitable candidates for mocking, whereas everything inside essentially is actually me manipulating state to get an effect. So I could say my handler is what I really want to test. I want to test that this behavior occurs when I call you that command or when I query you. All right. But I've got another talk about it, and I'm quite happy to come back at some point and do the more modern TDD talk to run through that.
Yeah, I've seen it. Yeah, you are doing this TDD talk. It looks really interesting. So in the end, you recommend to test the use case, right? That layer, right?
Right. So the command should equate roughly to one of my use cases.
Okay. Nice. Yeah, I had more questions. You already answered some of them. Probably the one that I wanted to ask is related to Brighter about the semantics of a command or an event, right? This is because when you are having an event handler or a command handler, what are the semantics of how the library it differentiates them? Or
can you rephrase that for me? So
for instance, if you can have an event or a command, right? So that basically
right, I see. What's
almost the same, right? Yeah, it's the same.
Yeah, okay, I understand that.
So yeah,
So we say that when you in Brighter, for example, what we say is a command only goes to one handler, right? So a command is expecting one person to answer it and effectively deal with its work. An event may be actually broadcast to a number of handlers, which may all take independent action. And generally, the idea is very much a CQRS kind of idea, which says a command is effectively an imperative instruction to do something, order my food, right? And an event is basically a past tense, which says something happened, food was ordered. And you can imagine in that scenario, we talk about the restaurant, right? I order my food, and probably a couple of things are interested in that in the event that gets raised. One is the kitchen, who want to cook it. The other potentially is the EPOS system that wants to basically add it to my bill, right? So that single command generates a couple of events. All right. Commands fail fast.
I think there are more questions in the chat if you want to take a look.
Yep, I'm going to look at that. So when would you recommend using a hexagonal architecture? Right, it's a good question in a sense. I'm going to step out from that question a little bit and say I would tend to think layered architectures are helpful at even fairly trivial examples. I actually think that introducing layers into even that simple kind of greetings app actually helps you manage the code you've got there, right? So layers are pretty valuable, right? Not necessarily using a tool like Brighter, but layers. Of those layers, an easy first point to get to feel comfortable that I've got something that essentially I'm not buying my way into a lot of over complexity in frame, which is a command pattern, right? And my query in the command pattern is just the same thing. It's just basically I just chose a different naming convention so I could see it as a query and a command. I would tend to think that's a reasonable pattern to use in lots of places, right? The other day I wrote a internal tool that we use at the place where I currently work. It is not intended for anything other than people inside to query some metadata that we have about systems. It's a command line tool, right? And it lets you set various flags and switches to ask for things. And all that's basically commands. It just implements as commands. It says this combination of flags is the use case. Here is a command that I can encapsulate that in. And it's very, very useful. Going beyond the command, right? And you can implement a command as a transaction script. So I don't have to have a domain model at all. It could just be basically, a transaction script of code, writing data structures database. I wouldn't really start to bring in dispatchers and that kind of thing, etc., unless I genuinely start to get some kind of model where I think, it's useful for me to have control of the pipeline because there are orthogonal operations happening all the time in terms of my observability, my reliability of the system. At that point is when you want to bring in dispatch because I lift that stuff out. Now I had to have a certain level of complexity that I couldn't just add that into every single endpoint. What is that complexity for you? I don't know, right? At a certain point you may say, I've got 10 handlers, they're all repeating this code around logging and wrapping stuff in poly, etc. I want to lift that out. Generally speaking, it's pretty easy to transition from a simple command pattern into a handler pattern, right? You're just splitting it in two and moving code around. So you can defer that decision until you decide I need that, right? But that's my advice would be, you can pretty much always use layers. You can pretty much always use a clean architecture style, which is dependent, which is pretty viable in any complexity of application, right? And a command is a really simple way of doing that. And it's not a huge amount of extra cost. You could do what I did, right? Effectively before that, which is just write a simple service layer that effectively has methods in it, right? If that's where you wanted to start, that's fine. The reason for showing you all those steps is showing you each one adds a little bit more. But you can start in that place where you just say, you know what I'm going to do? Not put code in my controller. I'm going to create a facade that essentially has code that represents each of the kind of different application workflows I run. They're all static methods on it. That's a starting point. At least my controller is clean of that. And I can write tests against those static methods. Anything more than that, I'll figure out if I genuinely need it. Right. But yeah, I would never recommend you use Brighter just for the sake of it. You want to use it because you want to run a pipeline or you want to do communication between processes. All right. You call your example over-engineered. Where would you make the switch from using a service directly or send a command, right? I mean, I think we've answered that a little bit. I think the command thing's probably okay, even in that kind of architecture. I would probably not think that a demo application like mine generally needs to have resilience against failures and circuit breaking and needs logging and all those kind of things, right? Command would be the point I get to and say stop, right? But I might even have to stop it for solve. I might even have to say that's enough for something like this, right? Because it doesn't really have an entity model at all. It has just operation scripts. Okay. Commands fail fast, events fail eventually. Kind of true, yeah, except that. Can you recommend any interesting framework a new Geek to develop with .NET to appreciate these patterns? Obviously, I would recommend Brighter to you. Mediator will do that for you as well. Mediator is nice and simple in that it doesn't come with. So Brighter comes in two parts, right? A mediator equivalent, and a thing that lets you with mediator turn mediator effectively equivalent into something that can handle messages and acts in the same way that say ASP.NET does for HTTP. We do that for messaging, right? Mediator is a good starting point, right? I mean, Jimmy built it to be a simpler version of all that. So you can start with that and say, hey, I like Mediator, but actually, you know what, I want to basically have some of the options about working out a process, and it's pretty easy to switch over. As I say, we came first, and the code looks kind of similar, so it's pretty easy to switch between one and the other, right? So maybe Mediator to start with, and then move to Brighter if you think you actually want some of the other special sauce that we have. Okay. Anything else? Questions?
Okay. I think someone asked about another question, CQS pattern. I've seen it.
I can talk to whatever the question is. So yes, I mean, CQRS effectively is what we are essentially doing when we say, hey, here's a command, here's a query, right? The interesting thing about CQRS and this kind of clean architecture model is that in proper CQRS, you have a different read model to the command model, right? So the question would be, well, how does that work in this kind of structure? And the answer really, from my point of view, would be the way you could kind of see it is you've got two almost separate clean architectures, right? You've got one where that application in the middle consists of entities that have interesting logic behavior, where my adapters around where my ports around the outside may lead to adapters that do have like micro ORMs in them to getting data in and out of the database, right? The other one essentially says, oh, well, all I've got effectively is a ports layer that has queries, but effectively the thing in the center is not really a domain model. It's just me querying my database right directly from the port layer. So my thing in the middle is actually my data structure, my database, right? And so what that means is that's kind of hollow. It's kind of hollow because there's this idea that I go from my port to my entity gateway, right, and return a result. So essentially in that model, I've got a kind of hollow clean architecture because I would just go from my port to my entity gateway, return the result, and I never go into the middle where there's an application, right? Another way of thinking about it is just to say it's all kind of one, but I just got stuff in the query that never goes into the application in the middle. That tends to be how I think about it. Is I tend to think to myself, the queries don't go into the middle; they just bounce around. But you can think of it either way. I don't mind. I know some people find the other way of thinking it was kind of a separate clean architecture where the center is really hollow and effectively bouncing itself. Up to you. But you can definitely get CQRS to work with it, right? Is Dark looking for live data applications in WPF, live sensor data in data grids? Wow. Okay, so I'm not a huge, it's been a while since I did kind of smart clients and things like that. So I am journeying, I have gray in my beard. So I'm journeying back many years to when I did WPF, which is quite a few. Probably, I don't know, it could be 20 years or so. Probably about 15. Yeah, it's only been around that long, so about 15 years. So would I use that? Potentially, yeah. I mean, you can have a clean architecture inside a what I would call a rich client. I guess maybe I may have a different name at one point, because you essentially have a boundary layer, which is effectively your interface, and you have potentially a boundary layer here, which basically is sensors. You may well have some SDK over that sensor, right? And you've got stuff in the middle where effectively you either are taking data from those sensors and responding in some way in calculations and showing stuff on the front end, right? in response to calculations, or maybe you're just interrogating those sensors directly and displaying without any kind of calculation, right? So one model, you've kind of got a command thing, which is saying, hey, I can press a button in my application that says, go and read some data and calculate something and give me some recommendation or whatever, a command model. And I've got one journey which says, hey, what I want you to do is just give me some sense data back. So it's going to go away and just do a query. And like I said, it would just basically skip around that port layer and not go into the application in the middle. Okay. If I did nothing, right, I had absolutely no command side logic, because there's no, I provided you no operations. I just essentially showed you everything on the screen. I suspect that kind of CQRS kind of model, everything else, might be a little overkill, but it still might be nice to have separation of, here is a query that talks to sensors and that kind of thing, etc. So I might stick at some sort of command pattern, we call them queries. In there, execute, I would go away and read the values of the sensors, and I'd display it back. It would still look like a clean architecture, but I might not really have much of an application if I didn't do any work with it. The application means I'm doing business work. If I haven't got one, I'm going to skip around the outside. It may be valuable to you to pass up individual units of this reads those sensors, this reads those sensors. If you've got use cases, right? If you have use cases for what I read, it's worth doing. It's not worth doing if you don't have anything like that. It would definitely be overkill at that point. But like I say, about 15 years since I've done any of that stuff, so you may want to figure out if somebody else is wiser than me on how we build that stuff nowadays. All right. So
yeah, I think, yeah, that's, we don't have any more questions so far.
The question to you, probably in terms of timing, then so you can all get away, is probably, I will run through quickly some highlights of what I have about Brighton, right? And most of it, you've seen a lot of it, but just a few other points that I'll call out. So let me see if I can share screen and show you that one. Hang on. Let me find that. Whoa, what's happened there? I actually didn't do that before. Find that one. Where are we? Too many windows. Okay. Can you show me that one, please? Okay, now Zoom knows about it. All right, hopefully you can see a slide deck now.
Yeah, it's okay.
All right, so this is going to be a bit of a highlight tour, run through some of the stuff, right? So we went with the demos. Okay, so Brighter usual sources available, right, on NuGet. It's available under Brighter command on GitHub. Look for paranormal.brighter effectively in NuGet, and you should find most of our stuff. The command processor is essentially the mediator equivalent. Service Activator is the ASP.NET kind of MVC equivalent, in the sense that it sets up basically reading messages off queues for you. All right. Then there are a number of transports on top of that that help you map to different messaging frameworks and different databases to help you support some scenarios like inbox and inbox. So overall, generically, we tend to call these things command invokers, but they're really CQRS. Either I've got a service endpoint, effectively HTTP. My command effectively deals with basically things that get activated, right? So command dispatch is just one way of implementing that. And we saw us talking about that earlier. So I won't run through that again. Okay. Maybe I to see this. So basically, you think you've seen this. If you look at the top left, we've got this idea of a greeting command. It's something that derives from actually command rather than iRequest, right? And then we just basically say those contain the parameters we need. And then we write a handler. And the handler, we say, takes an instance of that command. We do whatever operations we need on that particular handler, right? And we then register the handler with effectively our subscriber registry. You can see that on the right-hand side, effectively. And then to dispatch something, we just call send for a command or publish for an event. And as you said earlier, send sends to one target, publish sends to many. Okay. The interesting thing about Brighter we haven't discussed in that last scenario is wanting to be able to work with messaging. Okay. And the idea is that I have two processes, and what I want to do is send a command to another process or raise an event out of my process that I want to listen to. Sending command between two processes couples them a bit, but it can be useful where you say, hey, please, other service, do this thing for me. I know that you do it. But it creates basically coupling. It's a command-driven architecture. An event-driven architecture is nicer to decouple. I don't know who receives it, and I just broadcast events, say something happened to me, please respond, right? There's a difference in what we call choreography and orchestration. So choreography says a whole series of events get fired and things happen, people listen and respond to the various events. There's no centralized controller. And orchestration says commands get sent to people to do their work, and there's usually a central controller of the sequence. So typically what we might want to have is some sort of architecture which says, I've got a producer application that's going to raise events. That producer application may need to be able to resend those events. So what we may want to do is have something called a message store, which essentially says, I'm going to keep a copy of everything I've sent so you can resend it in future. It can also be used for what we call an outbox, but I'm not going to discuss outboxes today, it's too much. So what we have in there is an application, your code, and a channel adapter. That's something in Brighter, which essentially says, I will wrap away for you the idea of talking to a messaging transport. So that method post that you saw us do for that regreet is essentially wrapping around you're talking to basically, it's an entity, it's a gateway, and it's essentially wrapping that you're talking to a specific messaging channel. We define a number of what we call transports. So we can talk to RabbitMQ, we can talk to SQS, we can talk to Redis, right, and use them for messaging. We rely on there being what we call a broker. So some messaging is point to point, right? If I talk to an SQS queue in Amazon and you listen to the SQS queue without involving SNS, that's point to point. I can put a message on the queue as a producer, you can read it off as a consumer. If I use SNS in AWS, for example, that's a broker. That says I send you to the broker and the broker figures out who all the subscribers are and it gives it to a queue for that subscriber. RabbitMQ is a broker, right? I send to a topic on RabbitMQ that distributes to a whole set of subscribers. Okay. As you move on the diagram, you can see effectively the recipient list here. What we mean by that is there's some code in the broker that figures out who ought to be receiving this message and gives it to them. Commonly thought of as a pub sub, right? The recipients here effectively represent, I've got a whole set of queues, a whole set of consumers, all of whom have a queue which they can read from to look at. Notice I've got 3 reading from queues, right? I should have, there's an extra queue that doesn't really help understanding, so I'll ignore that time being. The top 2 are reading from their own queue, right? So they have their own copy of the message. The bottom 2, this diagram's a bit wrong, should really only have 1 queue, but the idea basically they're both reading off that same queue, right? And 2 things are off the same queue, we call it competing consumers. What they're saying is there's a lot of work on that queue and it's too much for one process to eat it. So I want to run 2 of these and they will basically alternate eating messages off the queue together. And they tend to do that by essentially having some mechanism for locking the message, which says someone's currently dealing with it, and to read past. In other words, I can read past anything that's locked and get the next thing in sequence in the queue, right? Doesn't work with ordering, right? Ordering tends to get breakdown. You can't do competing consumers with ordering. If you need to preserve ordering, you have to basically partition your queue into a whole set of queues based upon a smaller set based on a partition, right? So the big issue with queues is rate of arrival versus rate of delivery. Things arrive on a queue at a certain rate, and I want to basically, a rate of consumption, I want to consume at a higher rate such that my queue eventually empties. Competing consumers can help you do that if it's not ordered. If it's ordered, you can break up into more queues, right? Okay. So where does Brighter fit in? So Brighter basically, we said on the left-hand side is essentially providing that channel adapter and sending stuff to the broker. On the right-hand side is this thing called a service activator. So something like Web API is also what we call a service activator, right? In the sense that it sits there listening to basically HTTP requests. When it gets one, it calls your code. That's what we mean by a service activator. It says, I'm going to be the thing that listens for messages on the wire and I'll call your code. So we run basically what's called a message pump. We spin around saying, okay, tell us what queues to listen to. I'll listen to those queues. I will get a message off the queue, right? I'll do what's called translate. In other words, I'll ask you basically and say to you, the message has got a body. Can you turn that body in whatever format it's in, JSON, for example? Can you turn that into a type in your system? So I hand it to your translator. You can back a type, and I do what's called dispatch. I send it basically to a handler that essentially can deal with it based on the type information. So you can see that effectively we're able to use that command processor idea, that dispatching a command to a handler in both contexts, right? One in process, the other being called by our messaging queue, right? So in the first instance, I'm probably using Web API, which effectively acts as a service activator for me, and I'm dispatching to therefore a handler. In this context, I'm acting as essentially the thing that reads messages off the wire and dispatches them to your handler. What you can sort of post to where you send something to a queue is effectively you create a command and you just call post rather than calling send or publish. If you create an event, you can also call post. We recognize basically whether it's an event or a command. We add that information into the thing we publish. All right. We need to be able to serialize stuff so that it can appear on the wire. So this is what these translators are for. A message mapper. The message mapper just says you write some code that effectively allows us to basically take the type that you use for your message or command, etc., serialize it onto the wire and deserialize it back. Okay. This is basically actual implementation code. We can generate defaults for you if all you really want to just do JSON serialize the properties of your class. We've got a default you can use to do that, right? So you don't have to write that. It's useful to be able to have this intersection point because it solves a lot of problems for us. This ability to actually say, hey, I need to do something unique about what's on the actual wire. Handler, you've seen one of these earlier, right? Message comes in, we route it to basically a handler, and we let you put some more orthogonal operations in the way as a command processor. Okay. Don't worry about that. That's really old. Okay, what else want to see? Command processor. Kind of, yeah, this might be useful to you. The command processor is really what, when we talk about dispatcher, actually running this Russian doll model of saying, I don't just call your handler, I call a whole series of handlers in between. Look at that text. This diagram basically on the right-hand side is key. It's a kind of pipes and filters architectural style, right? The sink is the handler that you're writing that says, I am eventually the thing that deals with the request. The pump is essentially us in terms of basically the command processor. And we can put any number of steps for you in between you and that final handler, right? There's some suggestions on the left-hand side of a list of type of things that you quite commonly put in. Logging, validation, supporting item potency. So when I receive a message, have I processed it before? Because distributed systems tend to send me duplicates. So I can check and see whether I've had it before by looking, for example, at an inbox or seeing whether I have a version stamp on the entity and whether I'm later, right? And we can help other things like policies for handling exceptions, circuit breaking, etc. Okay, that's a wide range of things you can do. And we use this Russian doll approach for it, in the sense that we say each thing encompasses the call to the thing in between. And what that gives us the advantage of is basically lets you write essentially a try-catch block in data source, where effectively in the try block you call filter A, and essentially if something goes wrong, we can effectively then deal with it in the catch block, right? Or I can write some code which calls filter A and says, I've got some work to do afterwards. So I can write a logger that says I'm going to log before I call you, and I'm going to log after you've basically been called and control's going to return it back to me, or if there's an exception. Okay. So that's this Russian doll model, and it's slightly different to where you might get pipelines which are solely sequential. Okay. Very little tiny writing. Don't worry too much. It's documented on our documentation. We've got a lot of documentation. But essentially, to implement your own pipeline step, you do two things. On the left-hand side, you implement attributes. Standardware.net, basically, you create new attributes. We have a base class you can derive from to help you. And do you want to implement some stuff around what's the timing step and things like that, etc. for us? And all you need to tell us, the key piece of information to tell us is what is the handler type that gets instantiated in the pipeline when you have this element. And on the right-hand side, you just write basically a handler, and that's the same as all other handlers. It's a request handler, right? And you'll note, you may have noticed essentially, but in the handle method, it's not an async one, which you may be able to see here for our logger. At the end of your handle, one of the things you have to do is call the base class. You tend to do this method of call return base.handle or return await base.handle async. And that says call the next thing in the sequence. All right, we tend to always do that. Your sync handler doesn't necessarily need to do that because there shouldn't be anything after you. But quite often we just do it anyway. In a lot of our examples, we get really used to doing that. Pipelines, by the way, are usable whether you're using us in process or you're using us effectively in another process to handle messages. There's no difference to what we're doing in terms of dispatching and processing pipeline. The only difference is we add a piece of code that says, I will sit and listen to messages and give them to you. Okay, ignore that. Yeah, that's probably not that worth talking about. This is old school slides I used to write ages ago. I meant to write some new ones for this, but I didn't have time. But the old talks are for this. Circuit breakers, not everyone understands those, just in case. The terminology is a little bit confusing. So circuit breaker is this idea that when I have a circuit and it's closed, power flows through it. When it's open, it breaks the circuit and power won't flow through it. Okay. And the idea in terms of reliability is to say, sometimes I get a lot of failures, and keeping failing may not help me, particularly if I go into a retry loop, which may cost me actually quite a few milliseconds to do three retries. If it turns out whatever is downstream of me that is not working for a while, and also a whole retry swarm against them may not help it work, I'd be better off not doing that right now, breaking the circuit and essentially saying don't process anything anymore right now. Okay? And so what I would do is say, hey, in the event that I've got X many errors, open the circuit, nothing goes through. And then what the circuit breaker tends to do is say, after a timeout period has elapsed, let one through as an experiment. If that one that's gone through as an experiment succeeds, close the circuit and everything through. If it doesn't, keep it open and try again in a certain time interval, right? And one of the reasons it's particularly kind of useful is this avoiding me overwhelming downstream systems. Okay. And we throw a broken circuit exception, by the way, in the case we get that when you try and handle the code. The reason we do that is then you can catch that catch that on the outside or fail, right? And we, for our service activator, catch that on the outside and say, don't act the message out of the queue, leave it in the queue, right? So you're not consuming on your queue when a downstream resource effectively is not available to you. Work can just sit in the queue until we take one off and get it passing through and it works. Right? Okay, some configuration. That's what host builder now doesn't really matter. We do have some management and monitoring. No one's really using that. We need to look at it again. So inside of a control bus, we should be able to send messages to and from basically, going to monitor the status basically by messaging of any service instance, and we should be able to send messages to it to do stuff, right? We probably need to look at providing something that's a little bit more sympathetic to people who want to do Prometheus, etc. In theory, you have to write your own thing, listens to messages, and then effectively expose them to Prometheus. We may at some point soon give you something that does that. All right. That's probably all I wanted to tell you extra about Brighter than you saw in that last one. Apart from you just go to Brighter command on GitHub, which I'll show you. Actually, don't go there. Go to go.paramore. Let me just show you that link instead. No, get that link. Everything else I can show you. Introduction. Okay. So link there to goparamore.com. Let me just share my screen for a second. Right. So you've got a whole site here. usual kind of give you a pitch about what basically is going on. And you can go from here to see our docs quite easily. Our documentation tells you a lot about effectively how to get Brighter working, right? And then you can also go from there and navigate to see our project on GitHub. All right, so that's an overall org. You can see Brighter and Darker. Brighter is a Python version of Brighter. We really need to have a dark side at some point, it's a Python version of Darker. And there's the documentation that we've just been looking at, and some various tools around monitoring management. Work. There are also some other projects in here. One of them is this, which is to do backend SPM called Brighter. So I don't know if you know, there's a project out there called to do backend, and various people have implemented essentially the requirement to do that backend. Again, it's kind of overkill for what to do really is. But we did an implementation to show you how Brighter works, and you can see that in our list of projects, and you can go and have a quick look at that. Right? So don't worry about all the other stuff in there. Okay. All right, that's probably all I want to say to you, because it's almost 8 o'clock, and you probably want to, or 9 o'clock for you, so I want to go and